Hi, everyone, and welcome to our second week. Today, we're going to continue talking about hypotheses, and we'll also get into t-tests and testing for differences between groups, differences of variables, things along those lines. So I'll pull up, I'll do this all through VLabs. In one of my earlier videos, I was discussing how we can do all the work through VLabs, whether we're using Excel or SPSS. So you don't necessarily have to worry about downloading those programs. You probably already have Excel. You may or may not have SPSS, but nonetheless, you can access those programs through VLabs. So let me bring up what that looks like. Okay. So once you've signed on, so one of the things you need to do is you'll go to this vlabs.uml.edu. You'll get the VM software, and that you do need to download. But then once you've done that, you can sign in and you can go to Learning Commons. Just a second, is this? Yeah, you can see the VMware. And okay, so now it looks like, it looks like a desktop, but it's actually your VLabs that you're accessing these programs through our OneDrive cloud program. And so from here, you can click on the Start tab, and you'll notice, go down to E, you have Excel, you have Firefox, Google Chrome, whichever one you prefer. And when you go to I, you have the IBM SPSS program, IBM SPSS Statistics. Now I'm opening that. That can take a little while. So while I'm doing that, I'm going to open up Blackboard. And again, it doesn't matter when you sign on to VLabs versus when you sign on onto your desktop. It's going to look the same. Need to save that. Of course, I need to have to authenticate it, so that's all that was. No, don't do that. Let me just make sure that you can see exactly what I'm looking at. Okay. All right, so you can look at your Blackboard. Obviously, your Blackboard screen is going to look different than mine, but we can go to our class here. And you don't yet have week 2 available, but you're going to be able to see when you get in here. I've got a couple data sets here. We got the car sales data set that's in SPSS, and then you have a Kieran data set, which is in Excel. And that's what you'll actually use for quiz number 1. So just a little bit background on that. That Kieran data set is, Kieran's a Japanese beer company. If any of you have taken this class, the undergraduate version, you know I use this data set a lot. I'm just going to use it for this one quiz in this class. I'm not going to come back to it quite as much. But for Excel purposes, it's a really good data set. And it's got, customer information on Kieran customers, what they prefer in a beer, who they are as customers. And it's just really useful for learning how to do t-tests and just some of the initial sort of marketing analytics that we're working on. But today we're going to do the car sales data. So let me open that up. And let me double check, make sure that you can see exactly looking at here. Okay. All right, so here's what this data set looks like. You've got all the different manufacturers here, different models, so forth. And sorry, I've got to make sure it fits properly. And when we're running our analysis, everything can be found here under Analyze. And for this week, it's going to be using compare means. We have a few different types of tests we can do: paired samples t-test, one-way ANOVA. But you're going to see in the slides, I've already got all the directions printed out. So, you can follow the video, but you can also just look directly at the slides, which I'll go through, which will explain how to do all these different methods. So with that, I'm going to bring up our slides. Let's see here. Okay. Okay, great. All right. So this week is a continuation of what we discussed last week. Actually, I should change that to week 2, with hypothesis testing and how we test our results once we have run, whether it's experimental design or a large database, how do we work with this type of data? So last week we discussed formulating hypotheses. Now we're going to get into these other steps: selecting the appropriate test, looking at significance, and eventually getting to a marketing research conclusion. So just as a reminder, when you are developing hypothesis, generally what you're thinking of is what's referred to as an alternative hypothesis, in which you're expecting some difference between two variables or two groups. You're hoping to find something. Every alternative hypothesis has a corresponding null hypothesis, which is a statement of the status quo, where in this case, you're thinking that there's going to be no difference between two variables or no effect. No effect would be when we get into a regression. But for t-tests and ANOVA, it's no difference is the phrasing that we'll use. So really what we're trying to do here is we're trying to reject a null hypothesis, but we also have to have an understanding that we're never really going to be able to 100% accept or prove that really a null or alternative hypothesis is proven. So really what we're just trying to do is reject the null hypothesis with the hopes that they'll lead to some support for our alternative hypothesis. So as an example, let's say that we are the Kieran Beer Company, and we believe that our customers will place more importance on whether a beer has rich full body taste than on whether it is a light beer. The null hypothesis for that is that Kieran drinkers will not place more importance on whether beer is rich full bodied than on whether it is a light beer. So it's not the reverse, right? It's not that light beer is more important than full body taste. It's saying that there's just no difference. They're essentially, statistically speaking, they're equivalent. Whereas H1 or H2, whatever, that's how we denote alternative hypothesis is, H1, H2, H3, and so forth. The alternative hypothesis in this case is saying that full body taste is more important than light beer. So our goal is to reject H0, and hopefully we're going to find support for H1. My little note here, again, so we're looking for support. Kind of the idea here is that there's always another test, there's always another context. And because of that, we never necessarily just say that we have an absolute certain proof that we found something. Step 2 is we're going to pick our test statistic. In this case, it's going to be the t-test, or more specifically, the 2-sample t-test, also referred to as the paired samples t-test. This is really good for testing if there's a difference between groups. In this case, we have a group or variables. Actually, I should say groups or variables. In this case, the variables are rich full body beer and light taste. We want to say which one's more important. Now, every test that we do, whether it's a t-test, or you'll see an f-test later today, or a regression, or sorry, a correlation we're going to have an r-test. Whatever you do, you're always going to have a corresponding p-value. So when are we using a t-test? So let's start with that before I get let's discuss what is a t-test before I get more into the p-value. So when are we using this? We're doing it if we're looking for differences between two groups, two variables, two stimuli. So for example, researchers who do experiments might want to use a t-test to see if different stimuli provide different results. So here's an example of what that might be. Experimental design of testing two different website headlines. On the left, you have one where it's discussing the 30-day trial, no hidden fees, but it doesn't really discuss how long it takes to sign up. On the right, you have a headline that says sign up takes less than 60 seconds. So this was an actual test that a company had done to see which headline is going to work best. What they found is that the headline on the right, which tells respondents that the sign up takes 60 seconds, actually had a 30% increase in clicks. So they ran this as a real-time experiment. They saw which one worked better, and they said, the one on the right works better. We're increasing our click-through rate to 30% or 30% above what we have. And that's great. So we're going to stick with that language because customers do want to know roughly how long it's going to take to sign up. So this result, this can be tested using t-tests because we just have two different stimuli here. So if we think of experiments, I know in experiments, we think of like psychology, sociology, things like that. But in marketing, we do very similar types of tests, but we do it in the context of marketing. So in this case, how to set up a website. Google actually has their Google Analytics A/B tests actually have a really good process for running different types of tests. So this is a simple A/B test, a randomized experiment using two or more variants on the same web page. So I've got the link here, and I would certainly encourage you to take a look at it. It does provide some pretty good information for if you're interested in running a real-time experiment. Google makes it super easy. So, might as well do it, right? Get some good real-time information. So if you have your own website or, own online business, good way to test out, different graphics and different headlines, things like that. So I mentioned the p-value. So the p-value is the probability of obtaining a result that is equal to or more extreme than what's actually observed. The level of significance is the probability of rejecting the null hypothesis given that it's true. So let's say the null hypothesis is true. Let's say there's no difference between the click-through rates of those two headlines. Right? That would be that the null hypothesis is effectively true. We don't want to then reject it, right? So a lower probability is better. Significance is presented as sig or p-value, and you'll see some real examples of that in a few slides. And what are we looking for here? Well, we're looking for a p-value that is less than 0.05. That would tell us that the result is significant. If it's more than 0.05, the result is not significant. So why 0.05? Well, essentially a p-value of 0.05 means that the result would be supported as the opposite result, the null hypothesis, would be rejected 95% of the time. So let's say we run this experiment 100 times. Hypothetically, we're hoping that we would find the same, result, roughly speaking, 95, 96 times, 97 times, let's say. You're expecting to have some outliers, some weird results here and there. But if it gets to be more than 5%, then you're like, well, maybe there's something here. But if it's 5% or less, which is 0.05 or less, then you're saying, yes, we have a pretty good consistent result. So that's why we're looking for p-values below 0.05. In fact, if a p-value could be really close to 0, that would be the most reliable result that we could get. Continuing on, okay, what do we do with this now? Making a decision on H0. So let's say that probability associated with the observed value is less than the level of significance. This means that the null hypothesis is rejected. So let's come back to our Kieran example. What that would mean is that if we're using that Kieran example, it would mean that our null hypothesis saying that there's no difference between the two variables, rich full body taste and light beer, we reject it. So there is a difference. Okay, what is that difference? Well, we then would look at the means, and that's pretty straightforward. Essentially just whichever variable has the highest average, we say, great, that's the one that has a significantly higher result. We could do the same thing with the headline example that I showed you, right? So if you see that the click-through rate for one is higher than the other, and again, the p-value is below 0.05, which means it's not just a fluke, it means that it's a real reliable result. That means you'd say, yes, we reject the null hypothesis, and then our alternative hypothesis is supported. Whether that is that Kieran drinkers place more importance on rich full body taste than on whether it's light beer, or that you have a headline that tells you roughly how long it takes to sign up, will lead through a higher click-through rate. Which, whatever your alternative hypothesis is, a result where you have that p-value below 0.05 and you have one average that's clearly higher than the other, that's going to give you support for your alternative hypothesis. Let's work with some numbers. Let's work with some real examples here. So let's say I mentioned a paired samples t-test. So in SPSS, if we're using that car sales data that I just pulled up, remember, you click on analyze, you click on means, which I was showing you at the beginning of the video, and you would go to this paired samples t-test. When you pull that up, you're going to have a screen that looks like this. On the left here, it's giving you all the different variables. And really all you're looking to do is pick two variables and see if there's a difference. So let's say for this example, I want to see if there's a difference between the 4-year resale value and just the price, regular price. This is the result I would get. What I'm finding here, so let me point out a few things that are important here. First, that p-value. You're always going to be looking at the two-sided p-value. So whether you're using Excel or SPSS, this is what you're going to be looking at, is that two-sided p-value. And you can see here in the paired samples test, you're seeing two-sided p-value 0.001, that's below 0.05. We have a significant result. Next, once we've established that the p-value is below 0.05, we can look at the means. All right, so where are the means? Now you'll notice in the paired samples test on the bottom here, it shows you the mean difference. It's essentially just one variable minus the other, and as you can see, that's -8. I personally find it more useful to just go back to the basic statistics, where you can look at the actual values and you can see the 4-year resale value compared to the price in thousands. And again, these are in thousands, so you're getting a result here. You're clearly saying, one, the price in thousands is $26,095, while the average for the resale price is $18,059. Clearly, 26,000 is more than 18,000. And the p-value, coming back to where we started, that p-value is telling us that it's not only higher, but it's significantly higher. What does that mean? Well, it means that, practically speaking, that difference is significant enough that people will essentially, they're more willing to take on a used vehicle because the price is significantly lower. Hypothetically, let's say that the 4-year resale value was 25,000. That's technically still lower than 26,000, but it's probably not significantly lower. And that means that customers probably would not be willing to take on a used vehicle for only a $1,000 savings. But an $8,000 savings, The numbers are telling us that yes, that's a significant difference, and people would be willing to take on a used vehicle at that sort of cost savings. So what's this look like in Excel? Now, you can open these files and I'll double check to make sure that you have both the Excel version and the SPSS version in Blackboard, but you can actually open these files. They can kind of go back and forth. All you have to do is that when you click on one, you can right click on it and it'll give you the option of opening in a different program. So let's say you open the Excel version, but you then right click and say we want to open an SPSS, it'll allow you to do that. Nonetheless, I'll make sure you have both Excel and SPSS versions just to make life a little bit easier. Okay, so here's the data set. Here's what it looks like in Excel. Okay, again, I'm sorry, I didn't, I had the data set, I had it on the other screen. I'm just going to stick to this. SPSS, here's what it looks like in Excel. From here, you can go to Analyze and you can pull up the 2-sample t-test. From the 2-sample t-test, you then need to manually pick each variable, and it's a little bit clunkier in Excel. You do have to make sure, as you can see on the screen here, you have to make sure that you have the labels in the first row, and you have to make sure that you check labels so that Excel knows that terms like manufacturer, model, sales, so forth, they need to know that those are the labels. You then want to highlight each variable range. So in this case, the data goes from row 1 to row 121. Again, we've checked labels, so it's going to say, all right, row 1's just a label, so it's going to technically start at 2. And then you click on this arrow here next to the variable 1 range, and from there you can just essentially click and drag, or click and do Control-Shift down. Again, that's Control-Shift down, and that will highlight the entire column. If you're using a Mac, it'll be Command-Shift down. Again, the Mac is Command-Shift down to highlight a whole column. For other computers, it's Control-Shift down. So variable, you can also type it in, by the way. So if you want to just type in D1 to D120, that would work. And then variable 2, we're going to look at price, F1, F120. Labels are checked. Hypothesize mean difference, we use that blank because, again, we're looking to reject the null hypothesis. The null hypothesis is that there's no difference between these two variables. In this case, the alternative hypothesis would be that there is a difference between these two variables. So the goal is to reject the null hypothesis. So that's why we leave hypothesize mean difference blank, because if we can show that there is a difference, then we're going to get this result here. In the alpha, that's our p-value, 0.05. That's what we're looking to be below. So when you're setting it up, make sure that you set it up the way I have on the screen here. I'll give you just a second here if you need to pause or anything, just to make sure that you're on the same page. Okay, here's another thing. Excel is clunky. Excel does not like null or blank values. So this is going to be something I'm going to discuss throughout the semester, is cleaning data. Cleaning data is annoying, but it's very much a part of analytics. You can't do analytics without cleaning data. It's just impossible. So in this case, what we're going to do, you've noticed I've got these drop-down menus in the first row. That allows me to select just the null values. And from there, I can actually just delete them. So I could say, well, select null for resale and delete any response null. Do the same thing for price. So for both columns D and F, get rid of those null values. SPSS is smart enough to just not calculate those. Or sometimes it fills in, it kind of just comes up with an average. Excel's not that smart. So in this case, we do need to manually go in there and delete the null values. If you have blank values, you'd have to do the same thing. It's a bit manual, but it's, once you get used to it, it doesn't, with enough practice, it doesn't take too long. Now we can run our analysis in Excel. Again, make sure everything looks good. Make sure you've got all the variables highlighted. Okay, and here's the type of result you're going to get in Excel. So here's the thing. These are the same results that I showed you a few slides ago, but the format's different, given that it's Excel versus SPSS. We are still looking at the P2 tail. In this case, it just says 0.000. It's a really teeny tiny number. We don't really need to go all the way to like 20 decimal points. We just need to know that it's below 0.05. And yes, clearly it's below 0.05. By the way, the reason you use the two-tail is because if you think of a distribution curve, right, the normal distribution curve, the bell curve, it has two sides, right? Now, a bell curve is the same on both sides, right? But a lot of distribution curves are not the same. Some of them are skewed in one direction or another. And if you do just a one tail, you don't capture both sides. It sort of just assumes that it's normal. But if you do the two tail, it does capture any sort of skewness or bias that you might have. And so it's just a much more effective statistic to use if you're looking at two different distribution curves and you're not sure if they're normal or not. Assume they're not normal is what I would say. All right, so the two tail, again, below 0.05, just like we had in SPSS. In the averages, resale, same, 18,000. Average for price, 26. Okay. Hypothesized mean difference is 0. By the way, other things to notice, observations, 119, variance, we discussed that, what that means. We have a t-stat. T-stat is just a rough estimate for sort of the difference as two numbers get farther apart, the t-stat gets farther from 0. But generally what this tells you is that when the t-stat surpasses the t critical two tail, then it's going to mean that the p two tail is significant, is below 0.05. Extra information, to be honest, you don't necessarily have to remember all that. The key again is just look at that P2 tail. You see it's below 0.05. It means you have a significant result. Okay, now the example I just used was just two different variables at a time. But what if we have more than two variables or groups or stimuli? That's where we're going to use something called ANOVA, which is used to compare the means among 3 or more groups. One-way analysis of variance is used to determine whether there are any statistically significant differences between the means of 2 or more, although generally, honestly, 3 or more groups. The reason it's that is because t-tests are super duper easy to use, whereas ANOVAs are a little bit more confusing. So when you get to a point when you have more than 2, then I would say go to ANOVA. Let's go back to our car data to see what we can do with ANOVA. So is there a difference in sales price based on our car model? First, let's give each car maker a number. Here's why we need to do this. Even though SPSS is better, and certainly if you're doing ANOVA, you want to use SPSS, they still want some numerical labels here. Now, one thing I'm going to note about this data set is that there's only one model of Jaguar and Infiniti vehicles. SPSS will not run ANOVA on groups that have fewer than 2 cases, so you're not going to label those. So how do you label these? Well, oh, sorry, I didn't show you. One thing you can do is right-click on any column and create a new column and simply go through and create 1, 2, 3, 4, 5. It depends on how many different labels you need. In this case, I think it's about 30 or maybe 28, something like that. And so you can do this manually, just the way you would do in Excel, the same thing, just right-click on a column, introduce a new column, name the column, and then manually go through and give a label for each manufacturer. The other thing you can do, which might be more appropriate, is when you go to variable view, you can click on values and you can provide numbers for each manufacturer. So I'm just giving you a highlight here. You simply click on this plus button and you could go through and name the value and then give it a label. And in that case, then we don't actually have to create a whole new column. We're just labeling them within the existing column. Okay, once we've got this labeled, then we can analyze our results. Let's say we want to compare means. So analyze, compare means, just the same way we got to the t-tests. In this case, we're going to do one-way ANOVA. Let's put price in thousands in the dependent list. This is our dependent variable. In this case, it depends on the other factors that determine its value. Price could be determined by a few different things. Certainly one thing I think it could be determined by is the manufacturer, the brand. So now we've got, in this example, I've got label manufacturer here as my factor. So that's, I've created this new variable called label manufacturer. I'm going to put that into a factor. That's our independent variable, and it drives or influences our dependent variable. Makes sense, right? If you have a Hyundai versus a BMW, you would expect that the prices might be different. And the brand itself could be what drives that. Now, when you get into these results, you know, you have so many options. This is the kind of down, it's a good and a bad thing about SPSS. You have so many options, but it's overwhelming. So, you know, kind of just follow my lead here, and I can describe how to do this. So you want to click on post hoc and check to key. And then in options, check descriptive. Everything else should just be there already. Confidence intervals, again, that's that p-value, but now it's flipped, right? Before is 0.05, now it's 95. Same idea, right? Confidence 95% of the time, or you screw up less than 5% of the time, essentially kind of what that's saying. It's just presented differently in SPSS versus Excel. So make sure you have these, you know, these two things checked off before you run your results. And here are some initial findings. So when you're doing ANOVA, you're just going to get a boatload of results. Like I said, there's 30 different brand names here. Number 12 and 13, you'll notice are not here because that is Jaguar and Infinity. They only had one model here, so we didn't need to count that. And so what this is actually doing, you'll get this whole long list of these big tables that will look like this. So you should probably get, I think, 28 different tables that look like what I have on the screen. What this is doing is it's comparing the price of each model to all the other models, doing it one at a time. So you're just getting a boatload of data here, but you're still looking for the same things. So try not to get overwhelmed by the amount of data. Instead, look for the things that are important. All right, so number 11 was the brand Hyundai. This has the cheapest average price at a little over 12,000. Porsche, meanwhile, has the most expensive price at around 62,000. Now I'm curious, is the price between Hyundai and Porsche, is it significantly different? Little typo there, I apologize. But I'm curious, is there a difference between Porsche and Hyundai? I'm also curious, what about brands that we sort of compare? Chevy, Dodge, Ford, all sort of similar brands. They're all kind of in the same ballpark, 20,000 to 25,000. Are their prices significantly different? Let's look at the ANOVA table. So this is, when you ran your results, you're getting a bunch of statistics. This is going to be one of the other tables that you've got. This result tells us that there is a significant difference between prices. In this case, we're using the F-stat, so F value as opposed to the T-stat in the t-test. ANOVA uses F-stat, t-test uses T-stat. So the F value equals 6.330, p-value equals 0.001. We know that there is a difference between prices because p-value is below 0.05. The F value is similar to the T value, but again, used in ANOVA tests. And so, yes, there are differences in prices, but we want to know where do these differences exist? Let's go back to our Hyundai results. Actually, I apologize. Before we had just the general statistics. Now we can look at these tables and we can see specifically the Hyundai comparisons. So Hyundai prices are significantly lower than Mercedes prices, as their p-value is below 0.05. And the mean is, oh, I'm sorry, my apologies. That's Porsche. That's a typo here. Number 24 is Porsche. Let me see if I can. Porsche. Apologize. There we go. Well, you'll have to deal with my very terrible writing here, but yeah, number 24 is Porsche. And we know that the Hyundai prices are lower by 50,000. And we know that's a significant difference because we can see that the difference is 0.001. We see similar results when we compare Hyundai to number 15 Lexus and number 19 Mercedes, right? Big difference in the average price and p-values below 0.01. And I'm going to mention here, Lexus, you'll notice it's not 0, it's 0.007, but that's still below 0.05. So still a difference. So yeah, people are willing to spend more money for Hyundai, Lexus, Porsche. Of course, makes sense. What about if we look at Chevy and we compare this to other brands? Right, so let me highlight some things here. So number 8 and 9, those are Dodge and Ford. And yeah, there is a difference, you know, $4,000 difference, $1,000 difference, but the p-value, it's way, way above 0.05. So there's no significant difference there. Now, Chevy prices are, however, significantly lower than Lexus, Mercedes, and again, number 24 is Porsche. We can see, again, all below 0.05 for their p-values. So that's telling us that not only are Lexus, Mercedes, and Porsche significantly more expensive than Hyundai, they're also significantly more expensive than the Chevys, Dodges, and Fords of the world. So yeah, that means that the way people view those sort of luxury brands is different than the way they view, you know, Dodge, Ford, or Chevy. Here's the interesting thing. Chevy and Dodge and Ford, there are technically differences in their prices, but significantly speaking, there's not really a difference. I'll discuss what that means. So if Chevy has lower prices than Dodge and Ford, which we just saw, doesn't have an impact. Arguably, I would say no, not really, because they're technically different as much as $4,000 less, but customers don't really notice a difference, right? They're so far away from being a significant difference, and it makes you think maybe Chevy should just raise their prices. Maybe they're too cheap, you know, to be honest, because I'm sure customers appreciate a few extra $1,000 off, but it's not making a significant difference in the way people view Chevy versus Dodge versus Ford. Now, if BMW and Cadillac, now these are two other brands that you would generally consider luxury, but if you remember, they were not significantly higher than, you know, the overall brands. Should they raise their prices to be in line with Lexus and Mercedes and Porsche? Or maybe the current approach that enables BMW and enables them to reach the quote unquote average customer, so it increases their customer base. So maybe they're splitting the difference here. Maybe they know that their overall average price is not significantly different, but that's because they have some, you know, coupes and sedans that are a little bit more affordable, and they're able to reach some customers that maybe Porsche just doesn't have a chance of reaching. In other words, if BMW has a $30,000 car, that's obviously not the same as a $60,000 Porsche, but maybe BMW can take a few of those Dodge and Ford customers because their car, their entry-level vehicle is just a little bit higher than your average Dodge or Ford or Chevy. So, you know, that's where the numbers are helpful, but they don't tell you the answer. And I think that's kind of the lesson this week, is that the data analysis won't make important managerial decisions for you, but it will better equip you to make those decisions. So I went through a lot in this video today. If you have questions, I do encourage you to attend the weekly chat on Tuesday at 6 p.m. You'll want to complete the quiz that's due this week, due on Sunday by 11:59. That's going to be on that Karen data. And I will say, that's a bit lighter. I know I went through a ton of stuff, and I'm not going to kind of throw that all at you in the quiz right away. I've tried to make it a bit more, a bit easier in the sense that I don't want to quiz you on everything right away. I'll probably get to it in the test in a few weeks, but certainly in the quizzes, like I kind of want to, kind of start you off a little bit without too much heavy lifting. And then I want you to complete the discussion post. So what I'm going to ask you to do is to repeat the results that are in these slides, and just give it a shot. That's kind of what I'm asking for here is I want you to practice this stuff. I want you to post your results, and I want you to discuss your results with each other. See what you had trouble with, what you understood, what you didn't understand, and then maybe just discuss like some of the questions I had in the last slide, like, hey, what should Chevy do? What should BMW do based on the results that you saw here? Okay, so hopefully you got an appreciation for a couple different methods this week, the t-tests and ANOVA, and how those relate to hypotheses and hypothesis testing, and just some basics on experimental design as well. I didn't go too heavy into that, but just a little hint at the A/B type of testing. And like I said, if you do have questions, certainly show up for the chat, and I'm happy to go over those and show you some more results. All right, thanks everyone, and I'll talk to you next week. Bye.